Now we're going to introduce you about our project, which is QUITOR, Liquid Waste Remediator, application of Chlorella SP and Bacillus SP as household water waste bioremediator. As we can see here, there are two different layers. The upper one is the oil and the bottom one is the food scrubs. Semesta Bilingual boarding school kitchen doesn't have a good water waste rate. So everything from inside the kitchen directly go outside without being processed. If this happens continuously, the second background will become. So this is the fat deposits. Fat deposits will lead us to unpleasant odors and the water flow cannot go easily, and then water pollution. If this happens continuously again without being treated, ecosystem damage will be happening. Oil has a complex compound which is very hard to be broken down. Especially if it is in water, sunlight cannot come in, so the ecosystem down there will be damaged and die.
So from all of those problems, that's why we made QUITOR. What is QUITOR? QUITOR is the bioremediation method used to treat liquid kitchen waste in Semesta Bilingual boarding school by applying Bacillus SP and Chlorella SP as a bioremediator to produce output that switch to the domestic wastewater quality standards for BOD, COD, and CKN.
So for all of that problem, we can formulate it that can the culture of Bacillus SP and Chlorella SP be used as a bioremediator, and how effective is the use of Bacillus SP and Chlorella SP as a bioremediator in treating kitchen wastewater.
Now the aims. The aims of our project is knowing the effectiveness of using Bacillus SP and Chlorella SP as a bioremediator to treat kitchen wastewater, and then understand the bioremediation mechanism by Bacillus SP and Chlorella SP as a bioremediator in treating kitchen wastewater.
Now is the methodology of our project. The research that we use is the quasi-experimental research design with the non-randomized pre-test and post-test design. We conduct this experiment in Semesta Biology Laboratory and Laboratory of Microbiology in UNES, Universitas Negeri Semarang, and we tested in BBT-PI. The population that uses Bacillus SP and Chlorella SP. For the sample, we use liquid waste from Semesta Bilingual boarding school kitchen. And for the variables, independent variables is the different number of Bacillus that we use. Control variables is the Chlorella SP, water waste, and then the LMAR size. For the dependent variable, we use the reverse quality standard of domestic water waste quality and also the water quality for catfish farming.
The next one is the isolation of bacteria. The first one is making 100 ml of nutrient broth and nutrient agar, and then sterilize tools and material by autoclave. This is autoclave, and then pour the medium into the petri dish, and then the last one is isolate bacteria incubation for 24 hours.
The identification of the bacteria. Identification of the colony morphology will include the shape, color, age, elevation, size, and the texture. Identification of the cell shape, gram properties, and spore staining. And then the identification of bacterial cell physiology includes the catalase test.
And then the next one is culture Bacillus from kitchen waste. So the first one is calculation of the number of Bacillus SP using colony counter. This is the colony counter, and then the result will show up in the computer. And then the next is 1 oz colony of Bacillus SP was added to 100 ml of nutrient broth, and then cultures were cultured using an incubator shaker at 30 degrees Celsius at a speed of 120 RPM for 24 hours.
The bioremediation process, we prepare 6 different LMAR flasks. 5 of them we will do the experiment and 1 of them we will do the control. We put exactly 500 milliliters into 6 LMAR flasks. For the Chlorella SP, we also put 500 milliliters from LMAR 1 and LMAR 5. For the Bacillus SP, we started to give it from the LMAR 2. Started from 0.5 milliliters, and then 1 milliliters in the 3rd LMAR flask, 2 milliliters in the 4th LMAR flask, and 3 milliliters in the 5th LMAR flask. And after that, we put it outside so we can get a sunlight and do the process. And then the last step is testing. We do two types of testing. The first one is the pH testing, and the second one is the parametric testing, include POD, COD, and TKN.
And then the next is data and analysis data. As we can see in the result on the pH testing, the sample number 4 and 5, which use 2 and 3 ml of Bacillus sp and 500 ml of Chlorella, shows that the pH is 7. It means that the usage of Bacillus sp and Chlorella sp as a bioremediator is effective to reduce the pH test, the pH which says that the pH must be 6 until 9.
The result of the parameter testing, as we can see here, the BOD and COD has already decreased significantly from the control before. Maybe this is due to the duration and also the concentration of the Bacillus and Chlorella sp. That's why it doesn't reach the environmental standard. However, for the TKN, the number of the TKN has already reached the environmental standard.
So from our experiment, we can conclude that Bacillus sp and Chlorella sp can reduce COD, POD, and TKN level of liquid kitchen waste in the Semesta Bilingual boarding school. And then, bioremediation mechanism using Bacillus sp and Chlorella sp can be applied in the water waste treatment system of Semesta's kitchen. However, further research is needed to make the remediation product in accordance with environmental quality standards for domestic wastewater.
The future work of our research is the application of QUITOR for water waste treatment of Semesta's kitchen, with additional filtration process to make a clear filtrate so it can be used for watering the plant. In addition, further research can be carried out so the result can be used for fish farming, which will be used for Semesta's kitchen's needs.
It's the end of our presentation. My name is Fairuz Dharmawan, and my partner
Zahra, Maulida, Setya, Andini. Peduli air sekarang
atau merugi nanti.
Wassalamualaikum.